Okay, welcome back to our second video. We're looking at example 2 in 6.2, recursive procedures. So it says write a recursion formula. So we're now trying to come up with what the recursion formula is. So we're given the sequence here for part A, and now we want to find the recursion formula. So my recursion formula is always going to say one term is equal to the previous term plus something, or maybe it means a term is equal to 2 times the previous term. So we need to figure out what that pattern is. So it's always good to do that first. So um, part A right here, what's the pattern? So what's happening with these numbers? How do we go from one term to the next? So you can pause the video and try to figure that out. Just looking at it a bit, you can tell it's not really rocket science. The pattern here is they're kind of being multiplied by 2, right? Like 3 to 6, 6 to 12, 12 to 24. The only thing is they're negative, then positive, then negative, then positive. So um, obviously we're multiplying by negative to get the sign to change each time too. So the pattern is we are multiplying by -2 each time. Okay, you can see if you multiply by -2 each time, you can go from -3 to 6 to -12 to 24. So what does that mean? Well, if I'm trying to find any term in the sequence, I need to take the previous term and I need to multiply it by -2. So there's a nicer way to write this. I could just write it as -2 times Tn minus 1. Okay. This just means the previous term. Okay. Don't split this up into two things. This is a subscript, right? So this just means the previous term. Okay, so that would be my recursion formula. So just notice like the recursion formula is great for getting the next term. Okay, so here I only have like a few terms in my sequence, but if I wanted to know the 50th term, if I was interested in that, that means I got to do the recursive process another 45 times to get that value. Not really fun. So I would probably use the explicit formula instead. So the recursion formula, though, is great because it's when you can identify the pattern, it's really easy to write out the equation. Okay, let's look at part B. So that was A, part B. So I'm reading the graph. This is n, my x-axis. So this represents the term number. So first term, second term, third term, fourth term. And I can read the value on the y-axis. So it's probably helpful to write this out as numbers. So I can see my first term is 2. The second term is 6, and then the third term is 10, and the fourth term looks like 14. So what's the pattern here? Okay, we can see this is linear from the graph. We can also see that for each term we go up 4 units to get the next. So it kind of shows like a slope of 4. And we can see that right here, we're just adding 4 to get the next term. So kind of a simple pattern. So what's my recursive or recursion formula? Well, any term I'm looking for, I need to take the previous term. This is how we write out the previous term, just t and minus 1. And then I'm going to add 4 to it. Okay, that's it. It's probably good to check. So like if you wanted to know the fourth term, you could say t4 equals t4 minus 1 plus 4. That means t3 plus 4. T3 is 10. And I get 14. So yes, it definitely works. So you should always do that just to check and make sure you didn't make a little simple error somewhere. Okay. All right, the last one. So 3, 5, 8, 12. So sometimes the patterns are obvious. sometimes they're not. Okay, so um, I'm actually going to ask you to pause the video, take a moment, see if you can figure this one out. It's not very straightforward, so um, just hit pause and see if you can figure it out. Okay, so welcome back. So I'm going to show you a simple way that you can figure out what this pattern is, or something that's going to make it a little bit easier. So write out each term. So or try to write out the recursion process. So the first term is 3. My second term is the first term, and then maybe I can write it as like plus 2. Okay, because to get 5, I would have to take 3 and add 2 to it to get 5. Okay, what do I need to do to get the third term? The third term, I'd have to take 5 and I'd have to add 3 to get 8. So we would write T2 plus 3. Okay, and the fourth term is 12. I'd have to take 8 and I'd have to add 4 to it to get 12. So I'm going to write it as T3, so the third term plus 4. So notice you can see a little bit of a pattern happening here. Okay, we always take the previous term and then we add 2. The next time we add 3. Next time we add 4. It always seems like we're adding one higher than the term number. Okay, or we could even look at it like this. If I'm looking for the second term, I'm adding 2. If I'm looking for the third term, I'm adding 3. If I'm looking for the fourth term, I'm adding 4. So if I wanted to find the nth term, I would take the previous term and I would add n. Okay, and it's kind of as easy as that to get your formula. And I know it's not exactly easy, but you need to be looking for a pattern. So I showed you that because that's kind of a trick that could be used when it's a little bit tough to come up with the equation. So, and you might say, Mr. A, that's not really that great because it's like, this is the previous term, but then what's n? It's just the term number. So it's still a recursion formula because we're still using the previous term to get it, even though that there's an n in here. Okay, so yeah, that's it for this example. We just got one more left, so I'll see you in the next video.